it once more the beginning. The purpose of this polynomial difference of this polynomial is that we are easily going to have the approximation of the function with the help of the polynomial, and therefore this property is very important to have the approximation of the function with the help of the polynomial, and therefore this is known as a fundamental property. It has another advantage that it also gives rise to the concept of finding the missing values. If function is tabulated value is given, and in between if value of the function is not given, then we can also compute the value of the function. So here these advantages will be harnessed with the help of this property, which is very important. So far we have seen the differences between function and polynomial, and we have seen once more revisit and revise the previous lecture that all the polynomials are function, but all functions are not polynomial. We have seen it with the help of the numerical examples. So in single line statement, if you have to give the answer like this, what is the polynomial or what is the function, or how we can distinguish between the polynomial and function, then single point statement is, or the single line statement is that the conditioned function is a polynomial. And what is the condition? Condition is that the independent variable which is being involved in the function that must possess the non-negative integer, and that must possess the non-fractional values. This is simple two properties or two conditions which are imposed on the function, and function is allowed to behave like a polynomial, and that function then is called the polynomial function. So function, polynomial function. Now today here differences of the polynomial, then we have already discussed the merits or the advantages of this property, and later we will discuss further when we are going to apply this property. So this is the nth degree polynomial. As I have already discussed, the highest power of the x is known as the degree of the polynomial. So here we start from the highest power n, and we start and we last x naught, meaning thereby the function is what, the arguments, how many arguments we are going to handle. We are going to handle the arguments, the 0 and then x naught from 0 to n. Degree 0 to degree, if we talk about the degree is going from 0 to n. 0 to n means the number of, when we talk about the data, tabulated data, always you find the name of the tabulated data. So when we talk about the data, then data is what? Data will be n plus 1. Data will be n plus 1 because the x naught, x1, x2, so forth, so on up to the n. So data will be n plus 1. But degree of the polynomial is n. Data is n plus 1. Tabulated data is n plus 1. But degree is always n. So keep in the mind that number of data will be n plus 1. Tabulated data will be n plus 1. But at the same time, the degree of the polynomial will be n. So when we are going to handle the numericals, these things are very important, because when we are going to handle, whenever we handle the numericals, the many of the things which are memorized as a concept, that becomes very instrumental in solving the problem. If time and again you are remembering back and recollecting and retrieving your fundamental information, then this takes time, and numerical seems to be difficult in the solution process. So therefore, commit to your memory the fundamental properties. Wherever you are going to have, you capture it and you permanently transfer in your subconscious. This is the way of studying, particularly the subjects like mathematics. So degree is n, data will be n plus 1. This is a fundamental information or working tips for us. Now, what we are going to make it, spacing is h. This is spacing, I made you clear that this spacing is equal and we are using h. So very swiftly, very gently, x has become x plus h to the power n and x plus h again to the power n plus 1 and everything is going as it is. An, where h is the interval of difference or spacing as usual. So up to this point, I think there is no problem. From star and double star is the original polynomial and double star is what? That we have introduced the spacing h in the original polynomial. So this is the structure of the introduced h after introducing the h in the basic polynomial. So these two polynomials in combination, they are providing us what? Let us see. In combination means we are having here subtraction. Subtraction, the process of subtraction is taking place. Okay, so yx plus h minus yx, you look at here what we have done. For your sake, I have introduced this binomial expansion. This is the binomial expansion of this. Of what? Of x plus h to the power n. X plus h to the power n. This is the, and x plus h to the power n minus. This is the binomial expansion. How this is binomial expansion? If you remember, nc0 x n minus 0 h to the power 0. So in the first place you get k is equal to 0. So nc0 and then k is equal to x to the power n and k is equal to 0. So first term you get x to the power n and this will give you the factorial nc0 is what? Factorial n upon 0 factorial into n minus 0 factorial. So factorial 0 as a numerator and factorial 0 as a denominator and the factorial 0 is multiplied, so 1. So total is 1. Ultimately this is going to have, the first term is going to have the xn, if you remember. The first very term I am talking about. The first very term is going to produce the xn and second term is what? A naught x to the power n. So xn, when you take the common x a naught, that xn, that will be the first term. I'm not talking about the second term. So this xn will cancel this xn when you take the common a naught. What is second term of this one? Second term of this will remain as it is because in subtracted quantity, nothing is here except the x to the power n. Second term will be what? K is equal to 1, k is equal to, so nc1, x n to the power 1, x to the power n minus 1, h to the power 1. Means nc1 is what? nc1, the factorial n upon factorial 1 into factorial n minus 1. So factorial n minus 1, you just, this is factorial, this factorial n can be written, the factorial n, downside is factorial n minus 1, and above side is factorial n, so this may be written f n into n minus 1, and here is also factorial. Here is also factorial n minus 1, and here is also factorial 1 minus 1, n minus 1. So this will cancel each other. So ultimately second term will give you n. NC1 will give you n and x to the power n minus 1 and h. This will be second term. Second term will be what? The n and then x to the power n minus 1 n minus 1 and then h. To look at, this is the second term. Second term of this one. Second term of this one, this will remain multiplied by a naught. This will remain, and as a subtracted quantity, here is nothing. So this term of power x to the power n minus 1, this x minus 1 will come from here, and let us talk about this. What will happen here? When you talk about k is equal to 0, k is equal to 0, again this will be 1. Agreed? K is equal to 0 means factorial, and this will be factorial n minus 1 upon factorial 0 into n minus 1 minus 0. So factorial n minus 1. Factorial n minus 1 as a numerator, factorial n minus 1 as a denominator. So this will be 1. K is equal to 0. So this will be 0, x to the power n minus 1 and h to the power 0. So here what we are going to have? We are going to have x to the power n minus 1. Remember this very stage. This is not clarified in your book. They have simply written. If anywhere you try to get it, no simplification, no justification, they directly put the steps, and therefore you get embarrassed if you don't visualize the step. What is our problem? We have the limited power of the senses. If we are unable to visualize anything, it is not going to inside the brain. So visualization means how the steps works. So x to the power n minus 1 and coefficient is what? Look at a1, and here is what? Here is what? Here is also x n minus 1. The coefficient is a naught along with n and h. And here is also, here h is 0, so no problem. So here you will get the power x to the power n minus 1. And if you take common, then in bracket you will find a number of things. For example, you collect the coefficients and collects the terms of the x to the power n minus 1. This will be, if you collect it, here is n, and this it is multiplied by the a naught. You look at here, a naught. So a naught is here, and here is what? A1 x to the power n minus 1. Here you will find, if you sum a1 and x to the power n minus 1. Sorry, this screen is finished. N minus 1. So this, if you take this x, you are interested the highest power. So this will be common. So this will be this a naught n h plus 1 plus a1. So the coefficient will be different quantity. Similarly, when you take x minus 1, this x n minus 1, this will be cancelled by this x minus 1. So next we will get what? No, this is not here. Next we will get, or x2, we will get power x to the power n minus 2 here. So here will be cancelled, and here what we will get? Here we are getting this one. So this is the single power, but this coefficient has changed. H a naught n. So x to the power n minus 1 is this is the highest now. Means x naught is cancelled, x to the power n minus naught is cancelled, Now this will produce the n minus 2, and this will also produce the n minus 2 power. This will also produce the n minus 2 power. But every single, when you go for a2, the x itself, x n minus 2 next term will be cancelled. So this will give us x to the power n minus 2. This will start from here. X, this power will be cancelled. This will start from what? This will start from x n minus 1. Next term will give you what? X n minus x to the power n minus 3. In this way, this will continue. This will continue. I have shown only two steps, I mean two terms I have written after expanding binomial terms. Is it okay? This is very favorite. Binomial terms, expansion of the binomial is very, very favorite from intermediate, favorite of all of us. Simplifying and rearranging the terms. Rearranging the terms means power of the x, same power of the x will be kept at one place with their coefficients. With their coefficients means their coefficient is also important because we are going to form the new coefficient. So ultimately what we are going to have, you look at here, this difference is what? This is the first very difference. This is the first very difference I am talking about, nothing else. Of what? The basic polynomial is what? Yx. Basic polynomial is yx. First difference is going to a naught. You look at a naught is multiplying, nh you have seen, nh is multiplying, and x. The first difference, as I have shown, has given this term, this difference. I mean this one, this part is going to give us power x to the power n minus 1. This is a naught is here, and nc1 and n minus 1 and s to the power 1. So this very part is going to have this very part is going to have okay, this is giving this one, the first difference. Second difference you look at is giving, this was giving the x minus 1 was cancelled in the second difference. That difference starts with x to the power n minus 1, and naturally this coefficient has changed. In place of a1 we have written a1 dash or a1 prime. Why? Because a1 is not remaining there. We are going to have the sum of more constants, and therefore we have changed the nature of this, I mean a1 dash. Similarly, so for so on. Now we get the last term. Last term, if you have any doubts, you can look at the last term. How the last term is happening? Last term is happening, you look at this difference. Last term is what? K is equal to n. K is equal to n means nck, nc1, ncn. Ncn is what? Factorial n upon factorial n minus into n minus n factorial. So factorial 0, factorial 1, factorial n as numerator, factorial n as denominator. So you are getting 1. ncn is 1. This is also the nc1 is, this is 1, that is as a formula will come it in our memory. Now this is h to the power, this has become n. This has become n, and n minus k has become n. So n minus n is equal to 0. So x to the power 0 is 1. This is 1. This is hn. So this hn minus nothing. So you are getting hn here, you look at, and here you are going to have what? Here you are going to have h to the power n minus 1. So here h to the power I have made by arrow. You look at this point. Different ways to convince you. and this h. Next, what we will get? The last term, h n minus h to the power n minus 2. Next, h to the power n minus 3, so forth, so on. All are constant. H is constant. Therefore, all are constants. And all are what? They are being summed up. They are being summed up. So h1 plus hn minus 1 plus hn minus 2 plus hn minus 3 plus h, so forth on n minus n, that is the 0, that is the 1. So all these constants are summed up, and with the help of this, the new constant is made, and that very constant is an dash. An is also constant, if you remember here. An is also constant in the basic this one. Constant coefficient, but here you can look at the x naught. I'm not saying anything. N minus 1, and ultimately n minus n, x naught. So similarly, you can say this is a constant, or you can say the constant coefficient is rather true. Okay, so this very point you got, I think. Now you look at the first difference is ultimately we are going to have this one. The first difference. What is the degree of the polynomial after taking the first difference? You look at x to the power n minus 1. So what I would like to emphasize here, I would like to let you emphasize here that the first difference reduces the degree of the polynomial by 1. The first difference. The first difference of the polynomial of nth degree is a polynomial of degree n minus 1. Means degree has been reduced. Degree has been reduced. Degree reduced by 1. And if you take the difference, second difference, what will happen? Second difference. Proceeding exactly in the same way, proceeding exactly in the same way, you look at here, second difference. We have made the second difference. Second difference is saying the a naught n minus 1 h square x to the power n plus so forth on something, means we are interested in the highest power of x, and therefore this is n minus 2. And this degree is what? Degree is n minus 2. So second difference, n minus 1 degree, this gives us polynomial of n minus 1 degree. That is, if we repeat the process and compute another difference, then what happens? N minus 2 degree. Okay. This is n minus 2. Second difference gives n minus 2 degree. If we repeat the process and compute another difference, we have seen the first difference, we have seen the second difference. Second difference degree is n minus 2. Now we are interested in the nth difference. Nth difference of the polynomial is giving the value what? X to the power n minus 1. N minus 1, that is x is equal to 0. So here ultimately we are going to have x. Here it is free from. Now it is a constant one. Or you can say no sir, this will involve the x. Okay. So x you will involve. So x n means x n minus 1, that is 0. Now like this, n minus n. So x to the power 0. So it is, you look at free from variable. Variable means independent variable here. So nth difference makes the polynomial makes the value of the difference free from the independent variable. Means there is no variable, only constant quantities occurring. So if you go for next one, what will happen? Since there is no variable and variable is a must for deciding the degree, so if you take the difference n plus 1 means you won't get any value. Means if you go for higher order n plus 1, then the degree of polynomial, then you will get this evaluated value, this difference value, or this evaluated value of the difference 0. I means maybe n plus 1 difference, or the n plus second, n plus 2, n plus 3, more than n. More than n is n plus 1, n plus 2, n plus 3. You will get the value 0. So this difference is very important. Why this is very important? Let us take it. First point is that if we are given the polynomial and we are going to have the differences, then the nth difference of the polynomial having the degree n gives the constant value. And whenever we try to get more than this, since it is free from the x, so difference operates on the variable x or the argument x. What we do? We do x plus h. But x is not there. So where we are going to add the h? We are not going to add anything to h. Means the increment adding the difference, making the difference has no meaning. I think you may be getting my point. We always add x plus h. When x is not there, I say you have 5 rupees and you add please 2 rupees more, then you will say 7 rupees, sir, I have. If you have 0 rupees, I mean you do not have any rupees, then where you will add? So there is no process. If there is no, already you have no money, so you are not authorized to have the money with incremental value. Meaning thereby the having money is a precondition. If you zero money, if you have zero money, then you are not allowed to have the money. Like this polynomial says, because the difference only taking place with respect to arguments. So argument is finished, argument is over, or independent variable is over. There is no existence of the I mean independent variable, then not to speak of increment of that independent variable. So this gives nth degree polynomial. Maximum you can go for the nth difference and later you will get 0. Okay, let us see vice versa. Let us take this concept differently. Different people are those who makes the thing different. What is the difference between different? I mean, different people or different person. Person is a different who makes who conducts the things differently. Have you remembered this very popular proverb and saying that different person is a person who conducts the things differently. So differently we are making the arguments. Conversely means what? Nth difference of tabulated value. We are given the nth difference of tabulated values is constant. Okay, and higher differences vanish. Then what does it mean? You are given that higher differences vanish. Vanish means equal to 0, and the nth difference of the given tabulated values is a constant. I am not given the polynomial. Just we are thinking about the polynomial. If nth difference of the tabulated value is, we are given the tabulated value, we have computed the nth difference. after computing the nth difference, we have got the constant value, and when we go for the higher difference n plus 1 and so forth so on, then it is vanished. Then what does it mean? This means that tabulated values of given function, without function we cannot have the tabulated value, but we are not told, we are not given that what function you are going to handle, only tabulated values are given. So this function is hidden, you can say. Given function represents, then this tabulated value is represented by a polynomial of degree n. Means we can easily say that we are going to have a polynomial of degree n if we have the nth difference is constant and higher differences are 0, then we are going to have a polynomial of degree n, and this polynomial is going to approximate or represent the function for which tabulated data or value is given. So we predict this nature of the tabulated values. Nature means undoubtedly without function we cannot have the tabulated values. No and never possible without tabulated values. So behind this there is a function. So what is that function? That function is approximated, that function is represented by this degree of polynomial n. So this is the advantage of approximation of the function by the polynomial with the help of this fundamental property. But here the one thing is very clear, that arguments are equally spaced. I mean h we have introduced, and that is the equally spaced. And third, it constant. This analysis means converse can approximate the function by the polynomial. So what are two advantages of this fundamental property? The first advantage of this fundamental property is that we are going to have, or we are going to compute the missing values of the function or the tabulated values. And the second one is that that function is going to be approximated by the polynomial. So in this way, we wind up by this lecture, and if you have any queries we can have. So queries please. You can now unmute. I can unmute. Are you?
Sir, please come into single star and double star in combination. Give us.
Okay. Okay. Yes. Okay.
Sir, in this question, when we will put the value of k equal to 0, 1, and then in A0 it is right, but in A1 this
But
part
in
may be
but A0 is okay. I mean आप क्या कहना चाहते हैं कि A1 बदल गया और A0 नहीं बदला?
A1 में यहाँ जब वैल्यू आप k का इक्वल टू 1 रखेंगे, देन बाइनोमियल का थ्योरम जब लगाएं यहाँ से, तो n-1 n-2 अपॉन n-2 का फैक्टोरियल होगा, तो वहाँ सर n-1 बचेगा ना सर यहाँ पर, बट सर आपने वहाँ पर नहीं लिख रखा है
इस वाले में, इसमें जिस पर मैं हूँ yx प्लस h माइनस yx आगे वाले।
यस सर, इस साइड में जैसे सर, यस सर,
नहीं
k की वैल्यू जब 0 रखेंगे एंड 1 रखेंगे
ए की वैल्यू 0 का क्या मतलब, मैं ये तो कांस्टेंट कोफिशिएंट्स की तरह है, इनको वैल्यू नहीं रख रहे हैं, ये तो ऐसे करते रहेंगे। ये
सर
तो
यहाँ पर y(x + x - y(x) = a0 a0। यस सर। इन यहाँ पर सर k की वैल्यू 1 रखेंगे ना, n c k x⁻n - k, यहाँ जब वैल्यू रखेंगे तो इसको जब सॉल्व करेंगे तो और थोड़ा नीचे है सर, तो और जब सॉल्व करेंगे तो यहाँ पर n आएगा, एक तो यहाँ पर n आ गया, nh हो गया सर। और यहाँ पर सर, यहाँ पर आना चाहिए सर n - 1 h a1 n - 1 h into x⁻n - 2। चेक कर लीजिए सर एक बार।
आप उसको फर्दर सिंप्लीफाई करेंगे ना, तो फैक्टोरियल की प्रॉपर्टी से n को फैक्टोरियल की प्रॉपर्टी सिंप्लीफाई करेंगे, तो जो व्हाट एवर इट इज, मैं कोई आपकी वैल्यू में जो आप करके इसको देख लीजिएगा, मैं कोई कंट्राडिक्शन नहीं कर रहा हूँ, मैं आपको इतना कन्विंस करना चाहता हूँ, यहाँ का जो एक्शन है, ये एक्शन जो यहाँ का है, इस एक्शन को कैंसिल कर देगा और यहाँ पर n-1 मिलेगी, तो ये हाईएस्ट पावर होगी डिफरेंस की, ये मैं कहना चाहता हूँ। तो रीअरेंज करके आप देख लीजिएगा, जो भी आएगा वो तो लास्ट उसको इसलिए चेंज कर दिया गया है, आफ्टर a0 a1 a2 a3 सब डैश कर दिए गए हैं, तो चेंज हो जाएगा।
यस सर।
x⁻n-1 के बाद आपको कहीं नहीं मिलेगा, क्योंकि x⁻n यहाँ का होगा, ये भी इससे कैंसिल हो जाएगा, ये मैं कहना चाहता हूँ। तो x⁻n ये n-2 देगा, तो हाईएस्ट यही रहेगा, ये है इसके पीछे टोटल जो कहना चाहते हैं। ठीक है
जी सर, जी सर।
तो थैंक यू वेरी मच, दिस इज एनफ, आप इसको देख लेंगे। तो एनीथिंग मोर या
नो सर।
एक कैलकुलेशन आप बेटा जरा, आपके लिए इसलिए बायनोमियल मैंने यहाँ रख दिया कि आप इजीली सकते हैं। So okay, thank you. We are leaving from the meeting. Your
thank you sir.
Okay.
Thank you sir.
Okay.